Pick up a banana from any grocery store in the world and something strange becomes obvious the moment you actually look at it. It is identical, not similar. Identical. The same size, the same curve, the same pale yellow skin freckling, in the same way as it ripens, whether that banana was bought in Tokyo, Toronto, or Buenos Aires. No other fruit behaves like this. Apples come in dozens of common varieties, each with its own flavor and texture. Tomatoes range from tiny and sweet to large and acidic, but the banana, one of the most consumed fruits on Earth, is essentially a single product, manufactured by nature, but distributed like a piece of industrial hardware. Most people assume this is simply what a banana is. It is not. It is the result of a decision made decades ago that created one of the strangest and most fragile supply chains in modern agriculture. The common assumption is that the banana industry is just really good at farming, that decades of expertise have produced a consistent, reliable product, the same way car manufacturer refines an assembly line. That assumption is wrong, and the reason it is wrong reveals something unsettling about how far humans will go to optimize nature for convenience. The banana you eat today is not grown from seed. It cannot be. The Cavendish banana, the variety responsible for roughly half of global banana exports, is sterile. It produces no viable seeds at all. Every single Cavendish banana plant on the planet is a clone, cut and replanted from the tissue of another Cavendish plant, in an unbroken genetic chain stretching back to a single original specimen. There are billions of banana plants across dozens of countries, and genetically speaking, they are effectively one organism, copied endlessly across the globe. To understand why this happened, it helps to think of the Cavendish banana less like a species, and more like a piece of software that got copied onto millions of machines. Somewhere along the way, a particular version of that software, one specific banana plant, was found to have desirable traits: a pleasant taste, a manageable size, a thick enough peel to survive shipping, and a growth pattern that suited industrial farming. Instead of continuing to breed new versions through seeds, which introduces genetic variation the way sexual reproduction does, in most organisms, growers simply propagated that one plant over and over. Through cloning, cut a shoot from the base of the plant, replant it, and you get an exact genetic duplicate. Do that a few billion times, and you get the global banana supply. This is where the analogy of software becomes useful, because it reveals the danger clearly. If a single piece of software has a security flaw, and every computer in the world is running the exact same version, with no variation, then a single exploit can compromise every machine. Simultaneously, there is no diversity to slow the spread, no alternate versions immune to the vulnerability. Biologically, genetic diversity functions the same way. In a normal population, some individuals carry genetic variations that make them resistant to a given disease, so a pathogen can spread, but rarely wipes out the entire population. In a cloned population, every individual has identical DNA, which means every individual has an identical vulnerability. If a disease can kill one Cavendish plant, it can, in principle, kill every Cavendish plant on Earth. There is no biological firewall built into a monoculture. That is not a metaphor. It has already happened once. Before the Cavendish became the world's banana, the dominant export variety was called the Gros Michel. By most historical accounts, it was creamier, sweeter, and more durable than the Cavendish that replaced it. Through the early 20th century, the Gros Michel was the banana, cloned and shipped across the globe in the same genetically uniform way the Cavendish is today. Then a soil fungus called Fusarium oxysporum, specifically the strain that causes what's known as Panama disease, began spreading through plantations in Central America. Because every Gros Michel plant was genetically identical, the fungus that could kill one could kill all of them. There was no natural resistance to fall back on, because there was no genetic variation left to provide it. By the 1950s, Panama disease had devastated plantations across the banana exporting world, and the Gros Michel was functionally wiped out as a commercial crop. The banana industry did not solve the problem. It fled from it, switching to the Cavendish variety specifically because it happened to be resistant to that particular strain of the fungus. The switch preserved the business model. It did not fix the underlying vulnerability. It simply reset the clock on the same flaw in a new genetically identical population, waiting for the next pathogen suited to attack it. That clock is now running out. A newer strain, Tropical Race 4, has been steadily spreading across banana-growing regions in Asia, Africa, and, more recently, in America. And unlike the earlier strain, it is capable of infecting Cavendish plants as effectively as it once infected the Gros Michel. Once Tier 4 establishes itself in a plantation's soil, the fungus can persist there for decades, making the land essentially unusable for that variety ever again. This is not a hypothetical risk discussed in academic journals. It is an active, ongoing event. And the entire global banana export industry is built on a crop with no natural defense against it. Understanding why the industry accepted this level of risk requires looking past biology and into the economics that shaped the decision in the first place. Growing a genetically uniform crop is, from a business standpoint, extraordinarily efficient. A single variety ripens at a predictable rate, grows to a predictable size, and behaves consistently across an entire supply chain built for scale. Shipping companies can design refrigerated container systems around one specific ripening curve. Grocery stores can predict shelf life to the day. Consumers, whether they realize it or not, have come to expect a banana that always tastes and looks the same. And that consistency is what allows bananas to be sold cheaply and in massive volume, often for less per pound than many vegetables that require far less transportation. That price point is only possible because of standardization, and standardization is only possible because of genetic uniformity. In other words, the low cost of a banana at the grocery store is not just about cheap labor or efficient shipping. It is subsidized, in a sense, by an enormous hidden biological risk that the industry has chosen to accept in exchange for predictability and profit margin. Diversifying the crop, by contrast, would directly undermine the system that makes bananas so cheap and consistent in the first place. Breeding new resistant varieties from seed is slow, often taking many years, and the results are unpredictable, since sexual reproduction reshuffles genetics rather than preserving a known, marketable product. Even when disease-resistant varieties are developed, they frequently taste different, ripen differently, or don't hold up to the rigors of international shipping the way the Cavendish does. From a purely economic perspective, it has historically been cheaper and more predictable to keep planting the same vulnerable clone across a huge global footprint than to invest heavily in genetic diversity that might disrupt supply chains, alter consumer expectations, or reduce shelf life. The industry, in effect, made a calculated bet that the benefits of uniformity would outweigh the risk of another Panama disease-style collapse. At least for as long as that bet held, it is worth stepping back to notice how differently bananas were once produced and consumed, long before global shipping and refrigeration made a single export variety practical. For most of human history, bananas were grown and eaten far closer to where they were cultivated, in small farms and gardens containing dozens, sometimes hundreds, of different banana varieties, each suited to local soil, climate, and taste. Genetic diversity wasn't a strategic advantage in that world. It was simply the natural byproduct of decentralized, small-scale agriculture. There was no single global banana, because there was no global banana industry demanding one. It was only with the rise of large-scale export agriculture in the late 19th and 20th centuries, driven by steamships, refrigerated transport, and the economics of mass retail, that uniformity became not just possible, but necessary. The modern banana is, in that sense, a product of globalization as much as it is a product of nature. Its convenience is inseparable from the infrastructure built to support one specific, cloned version of the fruit, at the expense of the biological resilience that diversity once provided for free. What the story of the banana ultimately illustrates is a pattern that shows up again and again. Wherever humans optimize a biological system for economic efficiency, nature, left alone, tends to hedge its bets through diversity, producing countless slight variations so that no single threat can wipe out an entire population at once. Human agricultural systems, by contrast, often do the opposite. They select for the single best performing version of something, and then replicate it at massive scale. Because scale is what drives profit and predictability, that process creates enormous short-term efficiency, but it also quietly removes the natural safeguards that diversity provides, concentrating risk instead of spreading it. The Cavendish banana isn't fragile because nature designed it poorly. It's fragile because humans redesigned it, intentionally, in the image of a market that valued consistency over resilience. Whether the next chapter of that story ends with a scientific breakthrough, a costly transition to new varieties, or another slow collapse like the one that ended the Gros Michel's dominance, the underlying lesson holds regardless of the outcome. Every time humans simplify a natural system in the name of efficiency, they are making a trade, exchanging the messy, redundant safety of diversity for the clean, scalable predictability of uniformity. The banana on your kitchen counter is a small, everyday reminder of just how far that trade can go, and how quietly its costs can accumulate. until a single disease is all it takes to reveal them.